So next up, we have PCdog with RPKI validation.
So, good afternoon, everyone. After knowing how people invade embassies, now let's see how we can secure the underlying infrastructure, or in this case, the internet. So what I'm going to talk about is, in the first step, a little bit for people who have not the same background as me, is how does the internet actually work like? Relevant in this case also is what is actually BGP, why we need such a thing as RPKI, and how you can actually do that. If you run a network, if you run BGP, how you can roll it out. But let's first see what's the internet. Well, that's the internet, kind of. I think people, some people at least know where this has been. This has been the collocation at the recent event. I've been speaking about the same topic in Karlsruhe. So this is GPN collocation. You have to admire the professional stacking with mate boxes. It works. Anyway, so if we talk about the internet, we talk about IP. So there's two kinds of IP. There's IPv4, all you know, IPv4. Honestly, this is legacy. It's from 1981. This is older than most of us here. And I would like to start, because it should be legacy, it should be, stop being used. Let's call it IP legacy, so we can actually also shame all the vendors who still only support legacy on their new products. So when I talk about IP, I talk about IPv6. Sometimes I do a mistake, happy to be corrected. And yeah, by the way, IPv4, as of yesterday, RIPE now announced that with all the people joining RIPE, they're officially going to be out now. So if you try to get IPv4 addresses, IP legacy addresses, RIPE will tell you, no can do, you're out. So the time is finally officially over. So a little bit more about lingo. A prefix, that's if you have an address, that's the fixed part, the part that whenever you name a host is always in front of it. That's the prefix, that's why it's called a prefix. And the internet, we only route prefixes, we don't care about individual host addresses. While, in this case, the host part is what's freely interchangeable, and you should not reuse, because, well, it will collide if you have 2 times the same host part. Going back a bit about what's the internet. So the internet is a bunch of networks. It's a big mesh. Everyone can run their own network as long as you have an identifier. You probably need an AS, you're an autonomous system. So you need an AS number to get your identifier. And well, you can't do much if you have a network, but you have no network addresses. So if you want to be part of the internet, if you want to be on that level, you also need a certain amount of prefixes, at least one. It can be IP or it can be IP legacy. And that makes you an ISP, an autonomous system. Well, okay, now you have a bunch of IP addresses, you have your net block, you have your AS number. Cool, your network runs, but how do you talk to your neighbor? How do you talk to Google? How do you reach Netflix? How do you reach your customers? How do you do your whatever, online streaming? Well, that's through 2 things. One of them is called peering, and one of them is called transit. So let's say I have a network here or let's say I have a network in Switzerland, and you guys are using SBB. So all I had to do is to ask SBB, hey, let's establish a cable in between. So people who are here on SBB and they send an email to me, it goes through a peering. I don't pay SBB a dime. SBB doesn't pay me a dime. We have, on a mutual level, on eye level, a peering, we exchange traffic. That's how it's supposed to be in most cases. But you can't do that to all of the other probably 60,000 ASs in the world. How do you run 60,000 cables across the globe? It's not going to be really financially viable. It's not going to scale. And also, it's a really messy ball of cables. So sometimes you're like, okay, why don't I pay someone to do that for me? Well, that's exactly what's called transit. So me, as a service provider, I have to pay multiple companies even, because I don't want to rely on just one. So I pay 5 transit providers now, and they bring me to all the world. So they are now contractually obliged to deliver my packets everywhere in the world. And obviously, transit is not free. Well, this is the reality network world, so you all know. And sometimes it affects BGP as well. So anyway, what's BGP? So BGP is a standard protocol. We're currently running version v4. And we mostly use it to exchange information because it can carry multiple types of information. So what I normally do is through BGP, I announce to the world, hey, I'm here and I want to be able to use NetBlock X. So I announce my prefix. And I also do that by telling, hey, by the way, I'm AS58299, and I have these prefixes. You can send your packets for these prefixes to me. It is pretty scalable. I mean, we're running it with millions of objects nowadays. So that works pretty well. It just takes forever to load, depending on the router you have, depending on the vendor you have. It takes 20 minutes or 1 minute, so it really depends a bit on that. With BGP, well, it runs fine, it runs very well, but it was designed in a time where there were a couple hundred, couple thousands of networks, and everyone knew each other, and people were like, yeah, nobody's going to do any crap on the internet, because, yeah, we know our colleagues, we know they're trustworthy. Well, yeah. So with BGP, if you just run it with an out-of-the-box configuration on your router, it just trusts everyone. So if you run BGP with me, I will tell you, hey, by the way, you can reach 888.0/24, which is the network for the Google DNS, and you will reach it from me. And because we have a direct route, you might actually prefer that. Well, yeah, what could possibly go wrong? I mean, Pakistan Telecom once demonstrated that. So, yeah, the first level of defense, that's been done since, I don't know, tens of years, is we put up whitelists. So we say, hey, this is what you can send me, this is the predefined list. You send me an email with the list of net blocks you announce, and well, we have a gentleman's agreement that you actually didn't lie. Nice concept, problem is it doesn't scale, and again, it's a gentleman's agreement because I have to trust my upstream. So if someone else had like, hey, if I give you a box of beer, can I also announce this object that is not mine? Yay! So people were like, we need a central place, we need a database for that. Yay, databases! Because nobody ever put anything illegit in a database. Also, there's like old net blocks from before there were even those databases that were not registered, and you can have a hard time registering it. So it can be messy. You can create your filters every night. You can just go in and say, okay, I want to auto-generate those filters, except your router needs to support that. And that's the next problem. So what's the next thing to do? I mean, yeah, cryptography. Nothing ever got wrong with cryptography. So let's add a PKI to it. Let's add, so the internet, as of principle, it's decentralized. So there's no central point of anchor, there's no central point of truth until now. So the current state of the art is to introduce a PKI into the internet. I'm not judging it, I'm not valuing it if that's a good or bad idea, but I guess people should make their own decision and also participate in the community. Do we really want to have a central anchor point in the internet? I mean, to be honest, let's say a Dutch court has something against Pirate Bay, and because RIPE, which is responsible for the RPKI database in Europe, will be forced by a Dutch court to retract the signature for whatever network they consider as a bad network now. And since RIPE is Dutch, they have to oblige Dutch law, and that's a current standard scenario. So once we have a PKI, a public key infrastructure, we're also opening doors to censorship. Censorship that might work better than DNS censoring in Switzerland, but that's a different story. And honestly, I really don't want my internet. Oh, sorry, that was. How the hell did I jump? Sorry. Let's go. I don't want my internet to look like that. Because that's what you get if you start breaking the internet. So let's briefly go back again to those regional entities. So we have 5 regional as in 5 regions of the Earth, network registries. They are the anchor point for RPKI. So since I live in EMEA, in European and Middle Area, since I'm here, I'm a member of RIPE. Since I'm a member of RIPE, I have to put up the signatures in the RIPE Lear portal. So let's say I want to create a signature that I actually want to use this net block with this AS number, and I put a cryptographic signature to it. Then that looks like this. So you can see I have different net blocks. I have an IP net block, which is origin AS 13030, which is init 7. That's actually a net block I use outside of my network because I don't want to have everything with me. I can even so you who have the net block will sign it and not the ISP who uses your IP addresses. So you will also see indirectly when someone starts using your IP addresses and announces it. You will see, hey, they chose up. Hey, this net block is routed with this origin, and you're like, I don't know what that is. You can also use it as a monitoring tool. So I, for example, went in here and said, okay, I have AS 58299, and I sign that I announce the 185.4480.0/22, which is 1024 IP addresses. Now, going back a little bit to the Pakistan Telecom, back in the day, I think it's 10, 12 years ago, I don't remember. What was it? Do you remember?
It wasn't 7 or 8.
7 or 8 years, yeah. So what happens with Pakistan Telecom? The local telco registry, like in Finland that would be Traficom, here I don't know, in Germany would be the BNetzA, ordered the ISPs, and in this case the Pakistani Telecom, to block access to YouTube. Now this net block was a /23, 512 IP addresses, and some network engineer just tried to put in a rule, a so-called black hole route, but they created it as 2 times a /24. For whatever reason, probably they didn't know better. What they did not realize is because BGP as it behaves is when there's a static route, it will announce it. Now, if they had created a /23, 512 IP addresses, nothing would have happened. But because they created the more narrow announcement, all the traffic flew to Pakistan instead of YouTube, because base rule in routing is you look for the smallest net block, the most precise net block, the most precise route is the one you validate first. Why is this so? because otherwise your default gateway would always win, because that's the least specific route. So since you know we have a default route in most systems, like on your PC you have a default route, but you can add more specific, it's obvious that the more specific route is always evaluated. And Pakistan Telecom created a more specific route. Now, where can RPKI help us here? Well, fortunately, I can define for a net block here that I want to only announce it up to a size of a /22. So whenever something happens, even if a route comes up which spoofs my AS number, because that's also possible that someone not only steals my IP addresses but also my AS number, at least they're not able to capture all the traffic by suddenly announcing it with my AS number, but more specific. Because then they get all the traffic. This way they get part of the traffic, and only from the ISPs who do not do their job right, because you should never be able to hijack an ASN. And yeah, I mean, by the way, this is how you do management networks. You put in a copper SFP and you put it to the management port. Well done, guys. So, going back to RPKI. So, let's repeat again. You need an AS number, which you can get. It doesn't cost a fortune. You need a network block. Well, you can get PI space from sponsoring layers, so you can participate without breaking the bank. Costs you, I think, a total of 150 euro in setup fees with RIPE costs and stuff. You just need a friendly ISP. There's a few around here, I think. There's more than just me. And now you can start validating RPKI. I mean, there's different software components. There's something called a validator server that you need to run. I know about the Routinator 3000, which is what I was using, because from RIPE there's a thing called RPKI Validator, and this thing runs on Java. And I was like, okay, Java, no. I'm not even gonna look at it. No, just no. I don't know who had the brilliant idea to run this on Java, but no. Because now Oracle, if I run this, I guess Oracle, because it's Oracle, they will then come and say, hey, you have to pay licenses for it because you're using it commercially. I'm pretty sure. They do that with VirtualBox now. They check the download logs and they sue you for $1,000. That's what happened last week. Oh yeah, and with RPKI, if you want to run it, and if you want to validate what you're getting from the internet, you also need a capable router. And especially with a capable router, I mean routing software which can do RPKI. I think ViOS does it. Ubiquiti does not support it. Newer Cisco iOS definitely do support it. Juniper should support it. Older Brocade versions I have seen not supporting it. I don't know about newer ones, but I didn't see anything. And depending on, you don't need a routing software which also does routing, you just need something that speaks BGP to play with it. So you can also use something like, I think it's called BioRouting, but I don't know if it's actually BioS in there's no artificial stuff in it. Anyway, so, but you don't have RPKI yet, right? And normally what I have to do is in the config with VOS, I had to create a route map to say, hey, for this upstream, push it through the RPKI engine. So I wanted to get this working, to get this started. So it's actually pretty simple. You follow the manual, and then there's a terms and conditions file, a weird file that you used to have to download. I think that's finally gone now. But when I set it up, I had to download a file from Erin to claim that I've accepted their terms, and then you launch it, and it just starts downloading all those signature files, and that takes a while, and it's about to be rewritten that it's faster, but it took quite some time for me. And in the meantime, I went on and I had to fix an access point because the customer claimed the access point wasn't working anymore. Well, I don't know what's wrong with this. The Wi-Fi works. You see, the light is on. All peachy. You just put some super glue and tape on it. It worked again. So, if you have a wireless router, the slides I can upload again for reference. It's pretty simple. You have one statement which says, hey, for protocol RPKI, here's the IP address, here's the port, done, and we'll connect to the server downloading the validation. So that means you need a separate virtual machine which downloads the RPKI file, so you need a VM somewhere, and then you put it, you point your router to it. And then I'm like, okay, so I have an upstream, and for all the routes I get from the upstream, the upstream has a route map, AS whatever, and I say all of the incoming file. Well, check, and if it's RPKI valid, define the community to this. So BGP community is just like, put a sticker to it. If it's valid, tag it with 9100. That's artificial sticker, yellow sticker. For everything that's validated, I want a yellow sticker right now. And if it's not, put a red sticker on it. Right now, this was the first stage when I tested it. And you can also say RPKI invalid, just drop the route. If there's a route in a routing table which is clearly invalid, which is someone has put on a signature on their route and something went wrong, probably because either it's misconfigured or someone is doing something nasty, then drop it. It means if there's no RPKI signature on it, then it can be ignored. Nothing will happen. It will not be dropped and it will not be put higher. By the way, if you have a fiber optic connection and your signal level is too high, all you have to do is you take your fiber cable, you put it at a very tight angle, and because you lose some light, because it has to go those tight angles, that's how you do it. Or not. It works fine. It works fine for quite some time. Yeah. You can also use a pen, and you can just wrap your fiber around the pen. I think you lose about 1 dBm to 2 dBm per going round, so you can about measure it and then you tape it on. That's something called a penetrator. Some statistics I've made a few weeks ago. How many of those routes were actually signed valid? The numbers go up every week. I tested about 2 months ago, I think. It was about 100,000 routes which were fine. And interestingly enough, about 4,500 routes were marked as invalid. Out of those, most that I've seen that were invalid were routes where someone clearly defined no more specific, so no smaller prefix should exist, but they still did it. So that was kind of a problem. It does not cause any routing issue, it will just cause an issue of traffic optimization. So yeah. And if you then go ahead and you don't clean your router, do it like this, your routing will fail even without RPKI. A few sources. The local cert.net is one website that I've used some material on these slides, and also the whole what is RPKI, you can read more about it. And also, you can contact me on those things. So I prefer nowadays to use Matrix because it's easier to encrypt than anything else. And then something else happened. So I had this talk at GPN before, and I was preparing those slides, and then I got an internal message because the CCC has their nice postal system. And in the middle of the things, while I was doing the slides, I got this message. And I was like, oh no, now I have more material. So someone asked us on the GPN if we're actually validating, because the CCC, obviously, because we need a lot of IP addresses and we have a lot of network engineers. The CCC prefers to do their thing on their own, so we run our own network, our own ASN. So I actually went to the NOC and I was asking about more specific information. And so even the CCC, what they do right now is my status. We don't accept RFC 1918. Who here knows what RFC 1918 is? Come on, at least you know it. RFC 1918 is an old RFC saying 10.00/8 and 172.16/12 and 192.168/16 are used for private network and can be used wildly. There's newer RFCs who are similar, who set away 100.64/12 again, I think. So pretty large block, but 100/64 is to be used for carrier grade NAT, so it should not be used internal, but sometimes you see on your router, if you go to your router from your ISP, you see an IP address with 100.64, 100.65, and you're like, why can't I reach my webcam at home anymore? Well, that's because your ISP probably doesn't have any more IP legacy space left, and they probably have given you IPv6, so you should make sure you have IPv6 enabled on your network, and if they don't give you IPv6, start complaining to your ISP and leave them. So no carrier grade NAT, because that should not show up in the global routing table. You should never accept your own IP space. So if you go to the internet with your own network and someone else tells you that they have your IP addresses, trust me, there's something fishy going on. There's also IP addresses for documentation, like 192.0.20/24, and there's about 3 or 4 more example IP addresses for documentation. And I've seen people announcing that to the internet because they were literally typing down the documentation and thought it was a good idea. There's also special purposes for speed testing, should not ever show up. You should not accept multicast because you don't do IPTV. You should only accept IP address a certain length, which is nothing smaller than a /24. Same thing with IPv6. Nothing larger than a /19 should be announced because there is no ISP who has ever gotten IP space more than /19. So it really is interesting to look at the routing table and see what crap goes around there. I also use a different tool for that, so not biorouting, but I run Piranha BGP from another friend of mine, which is an awesome tool to see what crap comes around the internet. It's worse than you think. And yeah, the C3 NOC, we don't do RPKI yet there. Not enough people do RPKI yet. I think the only major network which does RPKI is probably NTT, but that's because of one of their employees is really pushing it. So yeah, in any case, make sure your network does not look like this. And this is seriously a wireless carrier here in Serbia. So this is a MikroTik router. On the left, you have this Wi-Fi card. You see actually the thin antenna cable coming out of it. This was on the roof, on the heat insulation, a cardboard box, a MikroTik in it, and then a thin cable going out to the roof, connecting to the antenna, connecting to the next tower. So for me, this was the state of internet here in Serbia sometimes. I know it goes better, so make sure to make it better, because that's what I found. And yeah. Any questions? There's also a BGP workshop coming up.
So when I run a validation server, how much resources does it come? So when I run a validation server for RPKI, how many resources do I have to allocate for that? What do I need with a dedicated machine, or is it okay with my CPU?
It's a
Megs of RAM or
it's a very small virtual machine. Let me briefly see. I'm not using that screen to type. Just give me a second because I don't want to mess anything up. But give me a second. Oh. Is it on the left or on the right? No, it's on the right. Oh, I need to stop. How do I zoom? I need to mirror it. Yeah, yeah, now I don't. Yeah, then come over and fix it, please. Just give me a sec. I also need to make it bigger. Yeah, give me a sec. Just. I don't have a mouse. I'm on it. Almost there. So that should be the same screen now. Okay, I also need another font. Mono bold, mono. Okay, everyone should be able to read that. Okay. Huh? Okay. Almost there. Okay, that's 151.31. 171 was it? Huh? So that's your answer. Right now it uses 80 megs of RAM. It has a decent CPU, which is a D1540, but it uses no resources. Yeah. It uses no resources. Sorry?
Type in uptime.
Whoa.
Ooh, that's a lot.
Oh yeah. So if there's one CPU, then it's quick.
Yeah. Well,
We have 80 megs of RAM.
80 meg is nothing. So yeah, you can run it on a PC Engine's APU easily. Not even an APU2 needed. Or an Alex. Probably an Alex will be a bit... So it needs more CPU because it has to be doing cryptographic validation. It has to check the signatures.
Yeah,
but that's it.
Basically on startup.
Yeah.
Once and then
Yeah, it updates every 15 minutes. Oh yeah, that's also a thing. If you run RPKI, it will delay you 15 minutes with accepting new routes if someone pushes it up at the same time. So you should always think ahead. Also, if you re-announce something with RPKI, it will delay you because people need to parse the new RPKI database, and I know ISPs who do it once every 24 hours, so you can't really change it that fast anymore. Yeah. More questions? And if there's someone here who wants to figure out BGP and has not done yet BGP, there's going to be a workshop on Sunday morning, I think. After Rakia leaks, so I would recommend to sober up fast, and also before Rakia leaks, eat. I know what I say. Eat enough.
So you're talking about cryptographic keys, and then they use an safe password.
Good point.
Do as I say, and others will do. Any more questions?
Can you just go back on slide links?
Which one?
I guess the sources.
Yeah.
Oops. This one?